is me. I went to RPI started in 2004. I went here on and off for a few years. Then I moved to Spain, did like some stuff. And then I moved to China, and then I dropped out of RPI. Now I work at GitHub, and I'm a developer, and I work on education stuff. So with people like you guys. So yeah, who here has a GitHub account? Okay, other way. Who does not have a GitHub account? All right, everybody, cool. So you all know how to use Git, so I don't need to say anything, right? So I'm guessing you guys aren't like beginners with Git. So if I'm boring you with anything, just raise a hand and say like, hey, we already know this. Let's move on to something more interesting. I guess the first thing that I need to say is if you go to github.com/edu, we give out free accounts, free private repositories for students. So if you use your rpi.edu email address, you'll automatically get this stuff. Professors, if you want your teachers to use this for like assignment submission, we give them free stuff. But I'll stop talking about that and get into some real things. So who would say that they're like a Git beginner? Okay, a few. Come on in, don't be shy. Let's see. So, this resolution problem. Is that text big enough to read in the back? Cool. So I'm just going to go through like setting up a project, and then I'll do a little bit of stuff about like how Git works underneath and why it works the way it does. So the first thing I'm going to do, I'm going to home directory. I'm going to make RCOS. This is I did RCOS twice. I think I was in the first group of RCOS students. So cd RCOS. All right, so I have a project folder. There's nothing inside of it. If I do git init, it's the first command you need to know. Git init. It tells you to initialize an empty Git repository, ls, and it created this folder here, .git. That .git folder is the entire Git repository with all of your history. All of your commits are in there, all your tags, all your branches, everything. When you push your code or when you share it with somebody else, that .git is like the soul of your project. So no person is there's no centralized like place where this is where the repository and all the commits live, and this is where I have the checked out version. The way Git works is you actually clone that entire history in one step, and then you can operate on that history locally without a network connection. So who here has used a version control system other than Git, like that's not that's centralized? So Subversion, CVS, okay. If you're coming from like Subversion or CVS, you might be used to like a central server. You say, I want to check out the latest edition of the code, and then locally, it copies all that down. You edit it and you make a commit. It's a little bit different in Git. So in Git, you have this like 3-stage workflow. It looks something like that. So you have like these 3 kind of areas. The working area is like your current working directory on your file system. The staging area is kind of like a shopping cart. You can like add stuff to it, take stuff out of it, and get it ready for committing. And then the repo is where the stuff goes after you've committed. And you can actually check out any point in history from the repo into your working directory. So to show how that works, I'll just create a README. And then I will use git add README. And then that has git status. That shows that I have a new file that I've added to my staging area, and then git commit -m add a README. And that's it. That walked us through working directory into staging into the repo. Now if I open up that README and welcome to, let's make this bigger, RCOS. Oh. README. Welcome to RCOS. Save it. And then I do git status. This is too low. Let me bring that up higher. All right. You'll see I edited the file. You can see that in my working directory I have a modified file. I can git add it. Git status. And now it's ready to be added. If I edit it again though, and then I say some more content, and then git status, what's going to happen here is you'll see it twice. So I've got it added to my staging area, but it's also modified in my current working directory. So I could make a commit right now, and what would happen is I would just get that first line added into my repository. If I do git add and then commit, it will add the whole 3 lines. So if I do git add readme, git commit -m, add some content. There it is, and I can use git log to see that I have 2 commits, and I can look at my project. You can see that it's got 1 file in it, it has 3 lines, pretty simple stuff. All right, everybody follow along with that? So, I want to show you something that's going on underneath. Let's see. So I've got a couple scripts here. I'm going to cd into RCOS on this one. /git scripts. Log live, history tail, 1 second, 25. All right. So this thing on the right is all the commands I've been running recently. It'll just, every time I run a command, so if you miss something, you can go back to that. And then put that here. And then down here, I'm going to cd into RCOS. And then I'm going to do git scripts, git graph live. And this will show you a few things. So you've got the commit identifier, the comment, when I did it, and then you've got these 2 yellow things, which are pointers in your repository. I'll explain it a little bit more. And so every time I make a commit, you'll see this like move along. And then this last one, cd RCOS -rf.git. So I'm just going to remove this hooks directory from the .git dir because it has a lot of stuff in it. So yeah, git. So let's see if I can make this one. Problem with low resolution is that it's hard to fit a lot of things on the screen. So here's what it looks like inside of the .git directory. I'll jump back and forth between this from time to time, but I also have this. Also have this like updating live. So we'll put this here. There we go. All right. So, like I said, Git has this three-stage thinking model. When you make a commit, something that's worth knowing is that it doesn't, you don't hit the network. And like in Subversion, for example, when you make a commit, you have to talk over the network, you have to send your changes. And the main advantage of using Git is that you can work without the network, without coordination, and it's great for collaboration because it helps you work on projects and make contributions without asking for permission first. So I'll show you some of that. I want to show you a typical version control system. So if you're using like Subversion, for example, you might be used to like 1, 2, 3, 4, 5 version numbers, and as you go from 1 to 2. You store the difference, whatever has changed in your repository. Version 3, whatever has changed, you store the difference. That sounds like it's a good strategy for saving space and not duplicating files, but it's actually really terrible. It's not actually that space efficient, and it's CPU intensive because you have to run all these operations to kind of assemble what the directory looked like at any one point in time. If you have questions, also raise your hand. Git, on the other hand, uses a directed acyclic graph for storage, and when you make a new revision in Git, so we don't use version numbers like 1, 2, 3, 4, 5, but if we compare it to that kind of system, when you make a new revision in Git, everything is copied. All right. Now, I'm kind of lying to you when I say everything is copied. What's actually happening is you're using hard links on the operating system level. So if you have 2 commits in your history, and you have 100 files in your repository in both commits, and only 1 file changed, it would be really inefficient to copy those 99 files again. So what happens is when you make the next commit, Git actually just uses a pointer to the existing 99 files and creates 1 copy of the new file with all the changes. So it's not storing diffs, it's storing the full copy of the file whenever anything changes, and whenever something doesn't change, it just uses a hard link as a pointer to that file. Let's see. So that's I have like this deck is like 2 days worth of material, so I'm not going to go through it all. But I want to. Yes.
Is there a way to see if a specific file is a hard link or a actual file?
What do you mean?
Link.
I'll explain how it's working under the hood.
Types of links.
So let's do this here. this one. Okay, so when I create a file in my project, so like I touch this example file, nothing happens here. Nothing. You saw, you were looking at this .git directory. I told you that this .git directory has everything inside of it, all of my history, everything. When I touch that example file, nothing happens. When I do git add example, I think nothing will happen again. Now, if I modify that file and say some text, and this is, now the content is different from anything I've ever put in my repository, and I do git add example, it pops up right here when I did that git add. And if you look here, git hash dash object, since you're all CS students, anybody not a CS student? Oh wow, okay. Well, you should know this stuff. I'll tell you about it in a minute. If I do git hash object example, you'll see it gives me this like output. And if you look over here, you should be able to find that output. Yeah, v6, this matches that. All right. So what this demonstrates basically is when you add something to the staging area, Git puts it into your objects directory. So the objects directory is where all of the Git objects are stored. And it names it based off of this hash. It uses a SHA-1 hash. So it takes the file contents, it ignores the file name, and it computes a hash. And if you don't know what a hash does, basically it's an algorithm. You put in some input. For the same input, you'll always get the same output. And if something slightly changes on the input, you'll get a huge change in the output. So you can see, like, we got this hash for my example file, and now it's here, v6, whatever. So the Git objects directory, I said everything is stored there. So what is everything? There are 4 types of things that are stored in Git. There are blobs. Here, I'll use a slide to show you this example. There are 4 types of things that are stored in Git. If you can read these numbers, some of them are inconsistent, so ignore that. But there are 4 types of things: blobs, trees, commits, and tags. I don't have tags represented up here. So when I did git add example, Git copied the contents of that file into the .git objects directory, computed a hash, and just stuck it there. And now my staging area has that thing in my staging area ready to be committed. When I make a commit, Git adds a new commit object, computes its hash, which is dependent upon all the trees and blobs underneath it. So it's got a bunch of pointers to these things. It computes its hash. It also sets its parent. So what commit is the parent of this one, which one was before it in history. And it points to a tree, which is the entirety of your project at that commit. So if I look at this objects there, every one of these things is either a commit, a tree, a blob, or a tag. And I don't have any tags, so it's a commit, tree, or a blob. All of these. So every time we've added a file, it's created a new blob, and it's stuck it into object, and then these are all directories that are the first 2 characters of the hash, and then 38 more characters of that hash. And then when we made a commit, the commit was created, and then a tree was created, which that commit points to. And then the tree points to the blobs that are in that directory. Everybody follow that? Anybody not understand? Okay, good. So let's see where we are. We have a new file called example. So if I do git commit -m add an example, what will happen is 2 more objects should show up in there. Why 2 objects? 1 for the commit and 1 for the tree. So since I don't have any subdirectories in my project, my project essentially, like, if you ignore this part, my project looks something like this. I have a commit that points to a tree. This tree is a directory that contains the files. This is my project directory, and I have README and I have example all in there, and this points to them. And you'll notice that this tree doesn't have a name. So when I check out my Git repository, I can check it out anywhere I want and call it wherever I want. The Git repository doesn't know what the project is called. The blobs also don't have file names, but the trees that point to them have the file names in the tree. So if you have 2 files that are exactly identical with different file names, it's only stored once. So this is why when you're using Git and you branch or you make a tag or you do anything, all the operations are really cheap, because once the stuff's added to Git, all of the high-level objects, commits and trees, are just a bunch of pointers to the blobs. So you can point to those really easily. Let's see here. So let's see. All right. So let's do this. This one here. So I have this script, git scripts, generate random changes, 3 main RB. So this script that I have, it just it generates some files, it puts some random changes in them, and it commits them one by one as if I'm doing work. This is how I do my job every day. It's really, really easy. I just write gem install code, and it does it. So you can see I just did some work. So we're working on some project, but say I have a new idea for a feature and I want to start working on it. But I don't know if I'm going to ship it. I don't know how long it's going to take me to do it. I don't want to get in the way of other people. So what I usually do when I start a new feature is I branch. And there's a command git branch, and you just type it like so, and then give it a name. So we'll call it experimental feature. I'll just call it experiment, so it's easier to type. So git branch experiment. And you'll see nothing in, only one thing changed. I got one new file over here called experiment. So it's in my .git there, refs heads experiment. There's just one new file in here, and if we look at that file, cat.git refs heads experiment, you'll see it's just a hash, and that hash is a commit. It's something in the history, and actually that hash matches this. So if you look, 3CE3097, it's there, and you can see in my nice log output that I have my experiment branch is now pointing to this commit. So these are all pointers. Master is a default branch that you get when you start a Git project. You can delete it and call it whatever you want, but it's just kind of a standard. It doesn't have any special meaning. Head is a pointer to what you've currently got checked out in your working directory. So if I went, for example, git checkout and gave it this commit number down here from the bottom, F0 whatever. Oh, that's not what I want. Why didn't that work? Copy. Git checkout this. You'll see that my head pointer moved down. And if I look in my current working directory, if I open up this project folder, where is it? If I look, you'll see I don't have any of these files called like main1.rb, main2.rb. If I go here and I do git checkout master, you'll see those files pop back up. So I did some work. My master has that work recorded in it. It's all the way at the front. But I can jump around to the history and make my working directory look like it did at any time in the past. So if I look at this README, which is, there we go. If I look at the README and I do git checkout and put in 2AB7183, and then I click over here, it disappears. All the content's gone, but the file is still there. So that was that when I first, go ahead.
What's the sub-L command?
Oh yeah, Sublime Text. It's my text editor. Okay. So you could just as easily use like VI, Emacs, whatever you want. So git checkout master. So when I use git checkout, this thing here, let's go back to this one. So like I said, there's these 3 different parts of the repository. I'm using git checkout to make my working directory look like the repo did at some point. I can give git checkout a commit number as an argument, like a commit hash. I can give it a branch, master, which is also just a pointer to a commit. I could give it something like master caret, which means 1 before master. So now you'll see that my head points to the commit just before master. I could give it master tilde3, which is 3 commits before. Instead of master, I could use 861A1E7 tilde3, and that will say 3 checkouts before this one. So 3 checkouts before. So you can give whatever you want on that command. And anywhere that you can give a commit, you can give any one of these kind of arguments that says traverse back to or whatever it is. You do like git checkout master. Like that, which is 2 before. I don't know if you can do this. I'll try it. yeah, you can combine them. So 2 before, 2 before. But anyways. So you should be totally comfortable with that stuff. If you're not, play around with it for a little while, get used to it, because this is a really useful tool to be able to, check out or clone your whole repo and jump around in space and time. You can make commits, you can jump over to your other branch and make some more commits, and then go back and forth between 2 different features that you're working on without having all that work collide until you're ready to merge them together. So like I said, we can use checkout to go to any point in history. But I can also use git checkout to check out a specific branch. So I can say git checkout experiment, and you'll see down below my head doesn't move. But if I use the git branch command, I get different output. So my experiment branch is selected. If I do git checkout master and then git branch, master is selected. Experiment. And what this does is it lets me specify where my next commit should go. And I don't like thinking of it that way. Like, which branch should I make my next commit to? It's not really what's happening. What's really happening is saying when I make my next commit, which branch pointer should I move forward with it? So if I make a commit now, so we're going to work on this experimental feature, random changes. First thing I need to do is I need to add a library, let's say. And it does that. And what you'll see is that master stayed where it was. It's still pointing to that commit in the past. My head moved forward because I'm in my current working directory, and experiment also moved forward because I had specified, git branch, that I wanna move that pointer forward. So we can do some work. Let's say, do some more changes to that one file, and add a couple more. So yeah, that's cool. It just looks like standard history. But now we find a bug in our project, and I'm not finished implementing my feature, so I can git checkout master, and you can see head moved back down to master. And if I look at my project, I don't have any of these random lib files in my project, and I can go into the main 1.rb and say, bug fix or something. Right? Just save that. Git status. I can see that file has been modified. I need to add it. Main 1.rb. I need to add it to my staging area. Git status. And now you can see it's modified and ready to be committed. Git commit -m fix the bug. And you can see down below something changed. Head moved forward by 1 commit, and master moved along with it because I had checked out master. But my experiment, it's still off to the side, so you can, do stuff off to the side. So I didn't have to finish my project, finish my new feature to ship that bug fix. So now, I fixed the bug, git checkout, experiment. Let's see here. Now you see head moved back over. You can see that my lib files are here. I might write some real code. Save that. Git add lib 3.rb, git commit -m. Cut some code. Oops. All right. And my experiment branch moved forward. I got one more commit, and you can see I cut some code. It's there. And now, I've deemed that this feature is ready. It's done. I want to give it to everybody else on my team. I could leave it as its own branch and share it with the rest of my team using git push, and I could just do something like git push, and then the name of where I want to push it to, and then this branch experiment. I'll explain this in a minute, but we're not going to do that right now. What we're going to do is git checkout master. So I really want to just get this into production. So I need to be on the branch where I want to put my code into. So I'm on the master branch. And all you need to do is git merge experiment. So you just say, you check out the branch that you want to merge into, and then you git merge the source of that code that you want to move in. So if you look at my project, this is currently what I've got going on. I don't have any of those libs. I've got my, let's see here, I've got my bug fix. I don't have any of those libs. And then if I do git merge experiment, it's going to pop up my editor and say, you need to give me a commit message. I'll just give the default. And now you'll see that this branch is joined back to the master branch. So this new commit is a merge commit. It has 2 parents. the parent, which was the experiment branch, and the parent, which was down here. And if I look at my project, I have all the code. No problem. It's all there. So that's fine. But what happens? Who's had like merge commit or merge conflicts before? Those are a pain in the ass, right? So I'll like contrive an example where we'll have some merge conflicts. So another thing to say is, so I told you that these branches, these names, these are just pointers, right? So after you've done your merge, it's kind of good practice to delete that pointer. So git branch. You see I have those branches there. I can do git branch -d experiment. And what will happen is it'll just remove that pointer. But it didn't remove it from my history. It didn't actually delete what we call the branch, right? Like everybody thinks about the branch as all this stuff that happened. It didn't delete that, it just deleted the pointer. So you can traverse the history, you can still view git log and get this stuff. But now when I run the git branch command, it's not in that list anymore. So if you've got like a huge team with lots of features going on, lots of different like branches and bug branches and whatever, like not tidying that up can be kind of annoying after a while. You definitely want to do that. So we're on master, and I can do git checkout -b. So this is, I want to check out a branch that I don't have, so I can use -b to create a new branch on the fly. So I'm just going to call it conflict, or yeah, I'll just call it C for conflict. So now I'm on that branch, and I can just jump into my editor and, welcome to RPI. Welcome RPI students, and then git add readme, so I made a change. Modify readme. Uh-oh, what did I do there? Oh, I combined two commands. Git add readme, git commit -m, modify readme. All right, so I have that change. You can see that my master branch didn't move. So I can git checkout master, which will take me back, and it goes back to welcome to RCOS. And like, for example, welcome to Troy, let's just say. Git status, it's modified, git add readme, git commit -m, cause a conflict, git status. So you can see, same example as we had before, just with one commit on each branch, they diverged. Git branch, I'm on master, I can do git merge C, which says merge the branch called C into this branch, and bam, I have a conflict. Merge conflict in readme, so I can look here, and now my readme has changed. It's got all this crap in it. What does it mean? So this section here, the two like delimiters, contains what was on that line in my working copy that I was merging into in head. What's down below between these two delimiters is what the branch that I was merging from contained. And you'll see that like these last two lines don't have anything around them because they were the same in both files. So I need to resolve this merge conflict, so I can say, for example, I need to delete this delimiter, delete this one, and like this is the compromise I want to make, and then I save it so it looks something like that. And then over here, if I do git status, it'll say both modified. So when you have a conflict, when you're merging in, the file that has all the files that have conflicts will have this status called both modified, when you have to go in, investigate, resolve the conflict manually, and then you use git add to add the file. Once you've resolved the conflict manually and saved it, use git add, and then if you do git status, it'll say modified. Great. So now we can do git commit. It pops up your editor, which says this is a merge commit. This is the message it's going to use by default, and it even notes that there was a conflict on this merge. So you could leave that there, or you could change it. We'll just leave it. Close that, and then down below, let's make this a little taller. You can see that that branch merged in with the merge conflict. So does anybody have questions that far? No? Yes.
I guess if you're looking for more things to talk about, you know what really annoys me?
What's
Fast forwards.
Why does that annoy you? Oh, you don't know what it means?
Yeah.
Okay, so I'll give you an example of what that is. It's actually really nice to have a fast forward merge because it means you're definitely not going to have a conflict. You're probably annoyed with non-fast forward merges.
Perhaps.
Yeah. So let's do this. I'm going to do git branch -d, delete that C branch that we merged in, git branch fast forward, git checkout fast forward, git scripts, generate random changes. I'll do like 4 changes to some file, text, whatever it is, right? So you'll see here, if I make this bigger, oh, it's too high up for me to point even. All right, there we go. So my master branch stayed where it was. I created this FF branch fast forward and moved forward on it by doing some random work. If I were to merge from master, if I said merge in fast forward, if you look at this, it's basically a straight line. From master, I just did one change, one change, one change, one change. I haven't made master diverge. So if I do the merge right now, it's called a fast forward merge. And the reason for that is it's essentially just a straight line of history. There's no work to be done. There's not going to be a commit like this, which is a merge commit, which shows that there are 2 parents, right? In this case, if I was to merge this into this, there would be one straight line, so it's a fast forward merge. So all of these have been non-fast forward merges. And then that's where you can get conflicts. Any other questions on fast forward merges, non-fast forward merges, this stuff? I have more to cover. I'm just making sure you're all on the same page. All right, so github.com, when you've written. All right, so, I should turn off staff mode. All right, cool. Let's see. All right, so far we haven't touched the network with our project. I've only created a project locally, done commits, done branches, merged them in. But for example, I want to share this code with other people. So what I can do is I can use GitHub. You can use other stuff. You can use Gitosis or something like that to host it yourself. I use GitHub. I work at GitHub, so it's a pretty easy choice for me. So let's say RCOS is the name of my project, and I just say giving a demo at RPI, create the repository. And so on my profile, you'll see John D. Britton /RCOS, and it has some instructions for me right here. If I'm starting a new project, it tells you what to do. But if I already have a project, it just gives me 2 commands, and I'll tell you exactly what they mean as I put them in. So this first command, git remote add origin and then a URI. Git remote is for managing remotes. Remotes are places where you can put code that are remote. It's pretty straightforward. Add lets you add a new remote. Origin is just a name. It's like a bookmark. Just like everything else I've been talking about, like branches and tags, like they're pointers. So git remote add origin says add a pointer called origin, and then that pointer should point to this URI. And when I do it, nothing happens. It just adds it. It doesn't hit the network. It's not verifying anything. The only time it will actually use that is when I use that like a bookmark. So now I can say git push, which is the command for sending my code. When you do a push, the opposite end of git, so the remote end, is done. All it does is it just receives whatever you send it. So git push origin master. And what that says is I want to push my master branch to the remote called origin, which we specified previously. So I do that, and you'll see it compresses and sends, and it shows that a new branch was created on that remote. And now if I refresh this page,
what's the -u in that command?
git help push. Let's see. Set upstream, which is upstream. For every branch that is set up, add a tracking reference. So if I have multiple branches and I want all of them to be pushed to whatever remote I'm adding, I can use -u.
Okay. So as is, you just push the current branch?
Yeah, I just push master.
Okay.
But actually, if you look at my project, Oh yeah, I have the fast forward branch. So that didn't get pushed, theoretically. Let's look. Let's look at make it brighter. Yeah, see, there's no fast forward branch up here. So I didn't use that -u, so that didn't include all of the branches. It was just the branch I specified. A really nice command, get help. It shows you a bunch of other commands, and if you use it, get help, and then the name of the command, like push, it'll show you the man page for that command. It's really good documentation, so definitely use it. So I've done that. I've pushed my project. It's not a very interesting project, but it's up there, and you can. I can clone this on another machine of mine with read-write access. So I can work on it, push-pull. But if you were to go here, you would get this URI, and you wouldn't have the option, because it's my repository. You wouldn't have the option to write to it under my namespace. But you could easily, since it's a public repo, you could easily just click fork, and that would copy it into your user space on github.com. You could clone it from there, and then you could make changes against it. So, anybody have laptop open? No? All right. If somebody wants to try that, go for it. I can use it to show how pull request works. Otherwise, I'll show you another way. What? Oh. You got a fork from your phone? That's pretty hardcore. I don't even write code on my phone. So yeah, so this is how you can go about sharing some code. If, for example, let's say Rails, say I want to contribute to the Rails project, I can just, I can fork it, and then I can clone it myself. I've got a project in my account that I contribute to that's not mine. It's called SWAT. This is what I use to determine whether or not you get free repositories as a student. So I've actually forked it from this guy named Lee Riley, who works with me. So here's the original repo. I click fork, it shows up in my account, and then I have this this URI, and I can just do git clone. This is the next command. So I'll make this in a new window just to show you. Git clone, and then paste in that URI. And if I don't give it any argument, it will create a directory called the name of the repo, or I could specify anything I want. And then, so since Git doesn't know what your project is called, because that top level directory doesn't have a name, when you check it out, there it is. So I'm just going to remove that, because I don't really need it right now. But, so that's, sharing your code, pulling code down, and then if you wanted to actually contribute to someone else's project, once you forked it and cloned it, you can make some changes, like in our case, I'm on this project, I do some changes, scripts, sharing is caring, no. Generate random changes, right? So I just do some random changes on my master branch. If I take this over here, this starts to get unwieldy on this resolution. There you go, sharing is caring. And then if I go back here, git status, I can do git push origin master. So before I do that, I'll hop over to GitHub, and I'll look at my RCOS thing. You'll see my last commit was merging branch C, and I can inspect that commit and see what changed, right? And then if I go back, I go back here, push, there it is, and then if I refresh this page, now my random change is up here. So that's all there really is to it. Now, in the case where you don't have permission to access a project, so we have this fast forward branch, git check out. In the case where you don't have access to commit to a project and you're working on your own branch, I can do something like this: git push. So I made some changes on the fast forward branch, right? And perhaps I want to propose them to the maintainer. That I want to say I want to put these changes into your project, but I don't have permission to write. I could fork it, create a branch, and then push that branch to my own local space. And when I do that, so git push Origin is just the name of the place I'm pushing to, and then FF is the branch name that I want to push. So I did that, and now if I go to my repository and refresh it, you'll see this thing here, which says that, oh, you recently pushed a branch, okay, another branch, and you can see in my branch browser that I have that fast forward branch available, and here's the code in there. But if I just click this compare button, it'll show me what's different between the master branch and the fast forward branch in that example. So I just added some random texts and files. And since I own this repository, I can just I can go here. Well, if I didn't own this repository, I would use something like pull request, say, I really want to fix these bugs, whatever it is, make a pull request, and now the maintainer of the software would get a page that looks like this. It says, oh, John has done some changes to your code, he wants to submit a pull request, here's what changed, here are the commits he did, and you can have a discussion with him like, this feature's crap, you need to like test your code, whatever it is, and then the maintainer gets this button. And in this case it's green because it's a fast forward merge, so it would be really easy to do. So there are no conflicts. If there were conflicts, this button wouldn't be green. It would say you have to resolve these conflicts before you can merge it. But I can just click this button and merge them in. And the other thing that's really cool is you can hook up service hooks on your repo to go run your unit tests and your continuous integration, and wire this button so that if your unit tests fail, this button will be red. So you can create a pull request, push it, or create a branch, push it, make a pull request, and then it will run your unit test and it'll show red. And then you can make some more commits. So if I go and say like, git branch, so I'm on the fast forward branch, I open up my editor and, make some change, git status, git add some file to, git commit, fixing some things as requested in the code review, git push origin ff, so pushing that branch again. And if I go to my my pull request and refresh it, there we go. There's another commit that shows up, and now my diff shows that I also did that. So you can use the pull request as like a code review facility. Also in that, let's see, my pull request. In that pull request, oh, somebody did something. Who's this? Who's Kubik? Hey. Let's code. All right. So in my pull request, I can also, when I'm reviewing the diff, I can write comments in line and say like, this doesn't match like our style guidelines, whatever it is, fix it. And then finally, I can click merge, and is awesome, whatever, and confirm the merge. And now all of that stuff is in master. It's available on the maintainer's page. And if I go to the network, for example, you'll see. It might take a second to generate. It would show you essentially the same output as this, which has all of the branches and merges in it. So, questions on sharing, cloning, pull requests? No? Does anybody have? I have a couple other things that I can cover that are like more advanced, like rebase and stuff like that. Does anybody have any questions that I didn't talk about that you just don't know what happens? Somebody asked one earlier about fast forwards. Yeah.
What happens when Git has hash collisions with object hashes?
That's a good question. So the short answer is that won't happen. 99.9999% certain. But in a given Git project, so the hashes aren't necessarily unique, or don't need to be unique across projects. You always have namespaced all these hashes into one project. So in order for you to get a hash collision in a project, it's like super unlikely. If it does happen, I have no idea what happens. I think the universe explodes. I have no idea. But if you really want to know, and you send me an email, I will research it and find out. Other questions about Git? Yeah.
Why is the graph viewer so broken?
Why is the graph viewer so broken? I think my internet sucks. I think it's actually my fault.
That's actually a common problem for me too, though, like wherever I am.
It worked for a while and then got slowed.
Yeah.
Let's see.
It's just slow.
The graph is there in the other tab.
Oh yeah, it's here? Yeah, I don't know what's going on.
It doesn't do anything.
Yeah. It usually works for me, but
What's it supposed to show?
it's supposed to show basically some lines going across that show like the master being developed, then a branch happening, and then you know, I could probably do git networks graph screenshot. This is what it's supposed to look like. Something like this. And then you can mouse over each of these dots, and it shows who made that commit and all that stuff. Yeah, more questions about GitHub? Anybody? No? All right. It's 5 o'clock. So are you guys like done at 5? Is that the thing? All right. Show of hands. Who wants me to go like 10 minutes more and show rebase?
Well,
5 to 10
we
minutes.
could have the people that want to stick around and learn the more advanced parts about Git.
Yeah, like just show of hands. If like 5 to 10 minutes more, it looks like some people want to see it. Okay, I'll do it. If you don't want to do it, just go ahead. I don't know. Unless you have some announcements, but I won't mind. Rebase. This is a useful command. So if I'm on master, git checkout master, and I make a branch, let's say difficult feature. So I'm working on some difficult feature that's going to take me like a month to build, right? Or it's going to take a really long time. And I don't know exactly when I'm going to be able to merge it back. And if I wait a month and the rest of my team keeps like merging their changes into master, the chances of having a merge conflict are really huge, right? Like the longer I wait to merge my changes back in, the higher the likelihood that somebody else changed something that I also changed. So when I'm working on a feature like this, I might, first git scripts, generate random changes, and let's say, let's do 4 of them on hard feature RB, right? So now I made some changes. Let's see if I can make this viewable. There we go. So it's hard to read, but you can see the colors, so that should be helpful. You can see I did some things. They went on master because I didn't check it out. Git check out. Git. Okay, here's another command that's useful. Git reset. Git reset -- hard head ~4. So what this does is it says go back 4 commits and erase them. Git status. All right. There we go. So let's check out hard feature. Yeah, right? Let's do this. New project. Git add readme -m first commit. Okay, and then I need to rerun this. Press live. Oh. Commit. There we go. Sorry about that. Git RPI RCOS. All right, git init. There we go. Touch readme. Git add readme. Git commit -m. First commit. All right. Now, if I do this correctly, RCOS and then graph live. There it's back. So I'm in this project, and I'm gonna not curse myself again. Git checkout -b, new feature. So I'm working on this feature, and I do generate git scripts, generating changes, 3 feature RB. So I didn't do any work on my master, but I just started doing some work on this feature. And in the meantime, my teammates, master. In the meantime, my teammates do some other work, like bug fixes, let's say. So I have a situation where my feature branch has diverged from master, but my feature is nowhere near done. Like, I'm going to spend another month working on this feature, and those bug fixes would be really valuable to have inside of this feature. So I wish I had waited to start this branch until here. I wish I had just like branched from here. So what I can do is I can use rebase to make it as if I had branched later. And the way rebase works is it's kind of like a tape recorder. You take take a given branch and you look at the commits you've done in that branch, and you kind of record them like in reverse order. So the most recent one, the one before that, the one before that, and you like kind of put them onto the stack and you hold them off to the side, and then you change your position to somewhere else in the repository, and then you replay those changes. So rebase, what I'm going to do is I'm going to say, I wish these 3 changes came after that, so that it was like I was ready for a fast forward merge. So I'm going to record these 3 changes backwards, move up to here, and then replay them, which will actually just put in a straight line at that point. So to do that, I need to check out my new feature, and then I use git rebase -i for interactive, and then give it where I want to rebase to. So I'll say master. So what I want to do is I want to rewind these 3 commits and make it as if they happened like off to the side of master. I could also just give it this commit number, and actually I'll probably do that just to show how it works. So you can give any commit, any master backed by 1, whatever you want. So let's just do it master backed by 1. Generally you would want to do it to master so that you have all of the latest bug fixes in your branch now. So I do that, and this text editor pops up, whatever editor you have configured. And it gives you this nice like menu kind of thing down here that tells you what all the words mean. But up at the top you'll see the 3 commits that we are rewinding, feature 1, feature 2, feature 3. And you see the word pick. So essentially I want to pick those changes and reapply them, so I've kind of like recorded them, and now I can do something like this. Instead of picking it, I can use squash. I can just type S or squash, and what that'll do is it'll say, when you're replaying these commits, replay this one and the one before it as if it were just 1 commit. So make all the changes into 1, and then in the log, just make 1 commit. The other thing I could do is for example, I could take one of these commits and just delete it and say, rewind it and then replay it as if that commit never happened. I could also reorder the commits. So now replay it in the order of the change I made to file 1, then the change I made to file 3, and then the change I made to file 2. So I'm going to do that. So I save this file.